People of the internet! In the last video on the Fisker Ocean battery pack, we met Will, who invited me along to document and help him take apart this battery. And yes, I did spend a lot of time in that video on all the stuff that Will won't need for his solution, but we did discover a few things. We discovered that this pack is built by CATL in China. We saw a lot of the controls and the management system that they used and how this was all arranged, and overall this looks like quite a solid pack. But we touched on some of the challenges that we're gonna face in taking this apart. There is still so much more to learn about this battery pack. Like, does it have a thick steel bottom so that when somebody drops their bike off the back of their family SUV, it won't pierce the bottom of the battery pack? No. No, it does not. How on earth are the cells in this pack? What's holding them in place? And what can we learn from how this pack is built? And what does that mean for the future of Fisker Ocean owners?
Yeah, it's quite soft.
I haven't poked that yet.
So
I presumed it was going to be like a plastic sheet. And above all, will be able to get these cells out of this battery pack. Yes, Will is taking these individual cells out and he's going to repurpose them into a lower voltage system using the inverter he already has.
Carving out a corner of the garage to stack it all on shelves.
Now in the last video, some of you said, why don't you just put your own BMS on the pack? Well, this isn't exactly what this pack's going to be used for. Sometimes moving 400 to 500 kilos of battery pack into a space that you need just isn't possible, and you just have to break it down if you want to make use of it. So yeah, let's get back to it as we try and work out what on earth we are going to do next.
I was just thinking I could throw an old sheet down actually over it to protect most of it.
Okay, so we're removing all of the aluminium framework to see how much we can get out of the way and remove, which will then allow us to lift the cells out of place.
No, these ones here in the middle.
Oh, wow.
Those three unthreaded, but the top one comes in two parts. I don't know where the other part is. I think it might be potted as well as
the other bit.
The batteries, all the potting has touched it and solidified it. I can take the lump hammer to it. My only thinking is it's like the other bits where they've still used bolts but parts of it are welded or riveted on.
Down. Because like this doesn't look like anything's holding it, so it must have screws from the underside.
Yeah, maybe.
But those don't seem to do any job in holding the cells down. They're literally just there as spacers, aren't they?
The screw bolts for all of these going down.
Is it worth trying to get some of the metalwork out before we go hacking the pack apart?
Because if we take all the screws out, we've still got to deal with these as well, haven't we? There and there.
Rivets will always pop out nice and easy with a drill bit.
You got any drill bits with you? That are steel ones?
I doubt it, but there's no harm in looking. No drill bits. You've got to take these things with caution, haven't you? One wrong move and this container's being sold on eBay as lightly damaged, may need some painting. Let's tackle this a different way. Let's see if we can break one or two cells out of the first module, and then once we've got an idea on how we might be able to remove that module, we can work on some of the others.
Because it's like done in groups of 4 as well. See how they're... Unless that's just where they're monitoring, maybe.
Get your voltmeter and have a look. 7.4, so 2 in parallel. Those two are parallel. Yeah.
Okay. I'll cut it here then, and then we can start peeling this back.
Yeah. Oh, it's such a shame in a way, isn't it?
Yeah.
Have you got spot welding equipment for cell tabs?
No, that'll be another part of the project. And carving out a corner of the garage to stack it all on shelves. start peeling up the sheet, I guess. See how bad it is.
Oh, they're bending all right. Oh, perfect.
Bring that down a bit.
These are the main bus bars that carry all of the current across the pack. With them nicely separated, we're not going to be touching these by accident. We have the balance wires in this as well, and on the one side you do have the potential of 30-40 volts, so you've got to be careful. You won't technically have a voltage between this pack either side.
We could check what each row is, can't we?
Yeah, find out.
It's quite thick as well.
29.9 there, which makes the entire thing about 60 volts.
Okay.
Should we measure a couple of the cells?
Let's just check the other side. And
so you got nothing there.
Yeah. Because
obviously the path goes up and down.
Yeah.
Do you want to run along some of them and see if the voltages match? If we just stick close together and measure. Yeah. So those are both the same side. So 7.48, or there is 7.48. 7.47. 7.47. So they're all pretty close, aren't they, along there? Yeah. And then it would be the same story on this side.
Cool. So do we start with just levering up from the bus bar and pulling it and peeling it along, do you think?
I think so.
Oh yeah. Cool. Yep. There's a quick way of doing it.
The number of 18650s I've taken the tabs off with those things. This will come as no surprise. These cell tabs are well and truly spot welded or laser welded to each of the cells, almost as if it's designed to handle a few hundred amps. We wanted to pry these up and gauge how difficult it was to just use the prying method. Of course, we left it there for lunch and picked up some drill bits on the way so that we could drill out these welds. So what's that? Just another couple hundred times?
Yeah. This is what I was meaning about repairability, people just trying to repair one cell.
The trade-off though is reliability of the pack. A pack that's better, that's more solid, that's got better thermal contact, is more likely to be longer lasting. But you're right, you lose the ability to repair a cell.
Because there's no way you can easily replace one of the cells and put this top sheet back on unless you've got a way of magically laser slicing across there. It's just not going to happen, is it? It's still cutting relatively easy enough as well. It'll probably peel off like silicone once you get to the front, but you know, like peel the cells out that way.
I'm sure you'd agree that these aren't the sounds you expect to hear in a battery workshop, but if we're going to try and take these cells out individually, this is the only way we're going to be able to do this. So, as with most battery packs now, they're not really designed to come apart. They're designed to be built in place, which ultimately gives more reliability long term. This is now bonded to that below. We're trying to take the side off, so there's an opportunity to pry away where these cells are held underneath. And at this stage, we're not really sure. There's a lot of aluminium. Everything is aluminium, at least it's not really hard steel. But we'll see, once we got this side off, what we find in the next stage, hey? Talk about not having the right tools on the day. It was very clear that we were going to use up our grinding discs very quickly, and we're going to need to take the bottom panel off anyway so that we can pull that side off. So Will had another idea.
80 kilos for each of these, so that's 160, 320, and we jacked up this frame while supporting that tray, I think it's enough to go.
The whole lot?
So yeah, so all the modules would stay in and it would break the plastics, but we jack it up kind of corner by corner to break it bit by bit. It's not going to make it any worse, is it?
So are you thinking remove all of those bolts as far as you can?
Yeah. You can see the plates separated now. There's an actual gap between that bottom plate and the frame.
So the cells are trying to sag down?
Yeah.
There isn't much steel in this pack, but you can tell from the sparks here that this is steel. There's a large steel nut on the bottom of the pack which kind of sandwiches the middle of that bottom plate, so we need to remove those, but of course we don't have like a 50-60mm socket with us. They're at home, aren't they? That is kind of sketchy, isn't it?
What, breeze blocks and bricks?
With the brick on top.
Yeah. We can put the brick flat if it makes you feel less.
What about just the breeze block?
40 of these, if not more. They support the main support struts running down vertically and some horizontally that divide up the modules. And our hope is that by taking these out, it alleviates the retention on them. So when we take out the very outer ones, the bottom plate completely comes away from the outer frame. May not work, but we'll find out.
So the CATL way is to put multiple screws and bolts to hold everything together. You can see this on the top part. There are lots and lots of these, but everything is kind of held together with this, with the glue, and there are some rivets in there as well. So it looks like the way they do this is they build the bottom plate of the pack and then they put these modules in to the sort of gluing material, which is obviously attached to that coolant plate and doing a job of transferring the thermals. But it's inside this like plastic tray. As far as we can tell, the plastic tray is the sides, but for all we know, this plastic tray could go entirely under. It wouldn't make sense to do that because that would then add more of a path for the coolant to make. We're expecting that we're going to need to break these off, or the weight will break it off as the pack goes out. So eventually this whole outer shell will lift up, leaving the remaining cells, the heavy weight, on a pallet. Okay people, how are CATL building these battery packs for Fisker, and how does that have a bearing on what we're trying to achieve? Well, retrospectively, it's really easy to work that out. So I'm going to demonstrate with some Mr. Kipling cherry bakewells and a baking tray. Okay, hear me out. These are a business expense, you know. I needed them for this video. Okay, so one cherry bakewell. Am I the only one that pulls these off before I eat a cherry bakewell? Anyway, so I think what CATL are doing is they're building the bottom. They are then putting the metal bracing in, which then means that when we have two of these, they are connected together through the bus bar, through the cell taps, and through the temperature sensors. They are then dropped down into the gluey material and fixed into place. We then, of course, do the same all the way along. And then our last two. That's weird. That one seems to have a bite out of it. Anyway, this then leaves us with our 6 modules that are connected in twos. But you now can't get these out very easily. There's no room down the side to get into them. You can't exactly pry against the cells because that could of course damage them or puncture them, which could result in fire that affects all of them. So really, you've got to try and break this frame up. Okay, so turning this upside down, one of the options Will might be going with is by basically cutting the bottom out of the section just a bit wider than where the battery sits, which then means he'll take that bottom surface out, which will be easier for him to then potentially pry it off or just leave it intact. But breaking the modules down into a smaller amount is exactly the goal for Will, instead of it being in a giant massive battery, because this as it is not usable for a guy that wants to stick it in his garage. So there we have it. That is how I think cattle are building them. It makes it easier for them to build them. They are very much a one-time use. You cannot replace individual cells in a pack like this. But given that the cost of battery packs second-hand isn't really crazy expensive considering their value in them, if I was to have a Fisker Ocean that was to die, I would explore those options, possibly keeping the original BMS. And that is exactly what they're doing. They are throwing all of their logic on the top to work with the Cherry Bakewells, the modules that are inside. Just as if you had a Land Rover that just out of warranty, the engine decided to blow. And of course, this has never happened to anybody, has it? You wouldn't buy a brand new engine from Land Rover. You would source a second-hand unit to drop that in. You do exactly the same with a battery pack if you had an issue with a cell. But it makes the pack more reliable. It makes them be able to make the pack cheaper because it's a really easy manufacturing process. It's quite clever, but yeah, we are moving away from individual cells being able to be replaced like we had once with, say, the Nissan Leaf. And this isn't just a Fisker Ocean thing or a CATL thing. This is way more common in the industry, and we see that in a battery, which I'm going to talk about in a future video. Okay, where was I? I think I was still trying to hack this thing apart. Okay, let's go hacking it apart. So, as we know, a battery pack is sealed, and this is what this large seal is around. All of these bolt holes together here, because the top is so flexible, they're quite close together. But what we're seeing here is the pressure relief valve. There's an opening here in the channel, and then obviously through this aluminium extrusion, it then allows pressure to escape through the outside vent, which is quite clever. There's one here and there's one here. There doesn't appear to be any other on the pack, but that's just really for worst case scenario. If there was some form of gassing out on this pack, it could do that. While I continue to eat Cherry Bakewells in my office, you've got to consider the sponsor for this week's video, Energy Genie. They've created a project that takes your inverter, your solar data, it takes your EV charger and your energy supplier data and crunches all of this and controls your devices in the most efficient way possible to save you money. Yes, it has a little cost, but it saves you more money. If you have solar, you're used to making savings from your solar system. You're used to investing in your system, which results in savings. So check Energy Genie out in the description below. Honestly, they're awesome. Right, Cherry Bakewells. Push down on this, let's see how much flex we got. Are we sitting on there or are we not sitting on there? That is the question.
Something in this corner is literally holding it on still. And I'm wondering if it's the...
So we've got an aluminium plate when we're removing, and then the next board up, yeah, it's aluminium on this side, but on the opposite side, it is sort of a plastic coating. The bottom plate appears to be completely separate from the cooling system, so it's just almost like a vanity and a protection, because if I probe into the coolant line, I can't feel it coming through the other side. Nice. You need decent protection, don't you, on the bottom of the battery?
Cool.
There we are. Look at all those bolt holes. I have just pulled the toolkit over, sorry. That was a lot of bolts holding that tray on. Right, so I'm going to do the mic test. You're wondering what is the mic test. The mic test is, does the magnet of the mic stick to it? And the answer is no. So it's an aluminium tray underneath. That kind of leaves it fairly vulnerable. You've got other packs with really thick bottoms, but this has an aluminium plate, and then presumably another couple of aluminium plates for the cooling path. Yeah, okay. This is another clue about the repairability of these Fisker Ocean battery packs. I would think in terms of battery damage, impact to the underside is quite a common one compared to other failure modes. If you look under there, there's more fixings. Yeah. Have you seen? At this point, we are looking for all the possible ways that this pack could still be held in place and stopping us from dropping it out. Maybe it's being held in by these pieces of plastic. Well, possibly, but we've also discovered a whole bunch of hidden fixings. Yeah. There's a lot of hidden fixings on this pack. It really isn't designed to come apart the way it went together. After all of that, hidden fixings making this pack very difficult to get apart. This really is a baking tin, and those modules really are cherry bakewells. Do you think undoing them is a good idea at this stage?
It's not going to change anything, is it?
That suddenly falls out once we undo these and ignore all the others, yeah? Well, we can see how long they are, can't we, and work out what they're doing.
Yeah.
In fact,
you can see how far that comes in there. When you look at the hole from there, you can see that protruding to about there. So you look that way, you can see this mounting plate juts out. It's almost like a double gallows bracket.
Okay.
You see what I mean? How it comes through to here.
Yeah, so something that slid in the rail.
Yeah.
So it doesn't go all the way through, it's just somehow mounting this down.
Yeah.
But what's so confusing is everything else that's connected to that big plate is welded in place.
Yeah.
Like literally everything else connected to it is welded, isn't it? I was trying to work out under here where these protrude through. There's a whole load of these.
Yeah.
And I was trying to decide if this one here is bolted. But you can see it doesn't, it's kind of fixed at that point. So this is held in by whatever that is going through.
So you want to, we take these off, then we can see if that falls out a bit, but that's...
It's held in place by these, then I don't from what I can see, they don't look like nuts.
Yeah. I think it'd be a sawzall to go there and there.
See those?
Yeah.
So there's a ton of those down there. And there's one here, which I've tried bending it against, but it's solid. And I can't work out whether they are, how they work. Are they a big washer and it's a hex inside? I probably need to get that.
Or is it like the central ones where it was layers?
We filming now for? Now it's reaching the time in the day where it's becoming obvious that we're not gonna get these cells out in time. I'm used to projects from home where I can stick on the sliders, have a go at an idea. If that doesn't work, come back to it. And over a series of weeks, you can pretty much achieve anything. But it's clear this isn't what we're going to be able to achieve in a day. It's so disappointing, but it just shows how they build the packs now, doesn't it?
Yeah, the structural packs out there. This is where it'd be nice if Cattle had made a public video on how the packs were.
How much are their cells to buy?
Oh, there is some movement in it though. Feel that?
Guys, a huge thanks to Will for inviting us down to take a look at one of these packs that you just don't really see out in the wild very much, do you? You don't see many of these, and as it turns out, they're very difficult to get into. And that is a problem for Will for another day, isn't it?
Yep, I am luckily going to spend a lot of time disassembling this as best I can.
More cutting disc, more different types of saws, I should say.
Maybe I'll get a plasma cutter. Speed it up a little bit.
Well, we've used the angle grinder really close to the battery, haven't we? We've done a few things which, you know, if we've made it this far without trouble, you should be fine the rest of the way. But it is a surprise on how tough these things are to get into. So maybe they are not Would you say they're great for home energy storage at the minute?
Probably not. No.
Yeah, our outlook was different at the start of the day, wasn't it?
Yeah, we were a lot more hopeful and misguided, maybe.
But there we are. It's been fun. You've treated us to lunch. It's been awesome to have met you in person.
You're welcome. Thank you very much for coming
Thank you.
and helping out, keeping me safe from catching on fire.
Awesome. See you soon, guys. Ever since I was a kid, I would love to take things apart just to learn how they're made. And I've been able to enjoy doing this with Will at his expense with his project. Honestly guys, thank you so much for watching. It means the world to me. Consider subscribing and drop a comment. Come on, let's talk about this. A bit taller as well.
I was going to say, yeah, I'll sit down here now.
If you want to know when my album's coming out, it's coming out next week.